By now, you must have seen many drawing sheets with engineering drawing on it. The basic engineering drawing methods and standards are common to all engineering fields, whether it is civil engineering, mechanical, architectural, surveying, etc. One common thing you must have observed, which is the drawing scale, or simply scale. Scale is always placed in the title block in the lowest box below the main title of the drawing, or sometimes it can be written at a place very close to the drawn object if different scale has been used at different places. This is very uncommon. Most common is to have only one scale for the entire drawing. In engineering drawing, scale is given by numbers in this format. Along with many other information such as the projection system, scale will also appear. Let us learn in detail what is a drawing scale and why we need it. Looking at this picture, if one tells you to make this kind of a stool or a table, the very first question you will ask is how big is it? It can be a very small stool, or it can be a large stool, or even a large table. We do not get any idea about this. Therefore, we do not know how much material we should buy, although we know the proportion of each part. Now, I will show you this picture in which same stool is being held by me. In this picture, you immediately get the idea of the size of the stool because you can compare it with the size of an adult hand. Roughly, you can even work out all the dimensions. In this example, I have not given anything except given a way to compare or kind of measuring tool in the form of my hand. This is the function a scale does. It provides a means to obtain the dimensions of the objects. Of course, in engineering, we would like to be more precise and systematic. Now, instead of showing my hand, I could also show this line and say that the length of this line is 100 millimeter. Using this as a scale, you can measure and calculate all the dimensions of the stool. The drawing scale does the same function, but there are some standards which we need to know and most importantly, practice. Let us look at the reasons why we need scale and then how it is defined. If the actual object is large, such as crankshaft or engine cylinder or piston or a building, we are drawing this object on our drawing sheet, then we will need to reduce the size of the drawing so that we can fit everything within the drawing space. Because the object we are drawing is much larger than our drawing sheet. The drawing sheet size can be A2 or A3 or this kind of size. If the actual item is very small, such as very small nut and bolt, and we are drawing this object on our drawing sheet, then we will need to enlarge the drawing of this object. Otherwise, it will be very hard to draw in full details and do the dimensioning because of very small size. But if the actual size is quite convenient to fit within our drawing space, then we do not need to either reduce the size of the drawing or enlarge it. In this case, we will draw the object on our drawing sheet to the actual size or in its full size. Scale in an engineering drawing is the reduction or enlargement of the dimensions on the drawing sheet relative to the actual dimensions of the object. So, for reducing scale, that means when the object is very large and we are trying to fit everything within one drawing sheet, then the reducing scale is represented by this 1:x, where x is the times the unit length has to be multiplied to obtain the actual dimension. So whatever unit length we have on the drawing sheet, we multiply by a number which is x here, and then we get the actual dimension. So for example, on the drawing sheet, if something is 10 millimeter and x here is 5, so actual size of the object will be 50 millimeter. So this is for reducing a scale. Enlarging a scale, it is written as x is to 1, where x is the number by which we need to divide the dimension on the drawing sheet to obtain the actual dimension. So in enlarging scale, the actual size of the object is small compared to the size on the drawing sheet. So we need to divide. So for example, if the size on the drawing sheet is 50 millimeter and we have x as 5 is to 1, then we have to divide 50 by 5, which gives us 10 millimeter. So that means the actual size of the object of that dimension is 10 millimeter. Based on this, there is something called representative fraction. It is given as length of the drawing divided by the actual length of the object. So always we bring it to either of these, we bring as unit. So either we write 1 is to x for reducing scale or x is to 1 for enlarging scale. So these are the two types of scale. Based on this definition, in engineering drawing, there are set number of scales which we can use. We should not use any another scale unless it is unavoidable. Always we should use either of these scales. So now for reducing scale, that means the object is large and we are trying to fit into our drawing sheet by reducing the size. In that case, we can use 1 is to 2 or 1 is to 5 or 1 is to 10. And similarly, we can use any of these reducing scale and we can draw the object on the drawing sheet. So for normal machine elements, perhaps 1 is to 5, 1 is to 10 will be enough. But if you are dealing with, for example, civil engineering or very large maps, surveying, then we might need 1 is to 1000 or even 1 is to 10,000. So this is how we will deal with the reducing scale. For enlarging scale, we should always use these scales. 50 is to 1, 20 is to 1, or 10 is to 1, or 5 is to 1, 2 is to 1. So these are the given standard reducing scale and enlarging scales. If the object size is such that it can easily fit into a drawing sheet, then we can use full scale, which means 1 is to 1. So that means there is no reduction or enlargement of the dimensions. It is exactly what the actual object is. Now I will try to show you how we can decide what kind of scale we should use for our purpose. Here I have got A3 size paper, so I'm going to show you drawing of the stool that I've shown you on A3 size paper. So if you look at the A3 size paper, it has got dimensions of 420 and 297, and then you will use some space for the borderline. So normally the trend is that we should use 20 millimeter on the left side, 10 millimeter on the right side, and above and below 10 millimeter. And here is the size of the title block. So this dimension of the title block is 180. This dimension can be 36 according to the international standard. 180 is common to international standard and the Indian standard. So if you do the calculation, on this side you have got a space of 210 millimeter. This side you have got a space of 230 millimeter. Normally for any engineering drawing, we have to draw at least 3 views: front view, top view, and the side view. And the fourth one we should also include is the 3-dimensional view, which is called isometric view. So we will divide this drawing sheet space in such a way that we can draw the main views on this side. And the isometric view we will leave here, because you should know that this space also can be used for bill of materials. So we should leave this space empty. So here we can make division such that we can find out a space for front view, top view, and side view if we are using the first angle projection system. So I have divided this space, which is 230, into 2 halves and roughly given this much space. So divided this space into half. So roughly given this space for front view, this space for top view, and this space for side view. So this is the space that we have got. Now I will put the photos of stool that I showed you. So this is kind of front view, top view, and the side view. Now we will need to know what is the largest dimension of the object you're trying to make. So that means we have to measure the dimension of this. So once the object is given, you take the largest dimension. So here the height of this table is the large, and we will use something like this much of a space. Okay. So out of 115, we should not use all space because there will be some space needed for dimensioning and for some other information. So we should use only part of this 150, only part of this 115 millimeter. So now we can do a small calculation. Okay. Here I have shown you how the isometric view of this object should look like. So now we can calculate the representative fraction as equal to length of the drawing divided by the actual length of the object, which is equal to length of the drawing is 70. So here I have decided that I will use about 70 millimeter for this height. Okay. So 70, I assign this length, this dimension as 70 divided by 410. 410 is the actual length of the object. So I'm basing my calculation on the largest dimension of this object. So 70 divided by 410, it gives me 1 over 5.8. So always you should show it in the ratio like this. So now that means I should use a scale of 1:5.8, but there is no 5.8 this kind of scale. So I should use a nearest scale. So the nearest scale is 1:5. After this, the next scale will be 1:10, but that will not be suitable for this presentation because 1:10, that means it's 10 times reduction and it will look very, very small here. So always remember that whatever space of the drawing sheet we have, we should try to use full space. So in order to use the full space, we should use a scale of 1:5. So I have written here scale of 1:5. So on this drawing sheet, which is A3 size paper, I will draw this stool, the front view, the top view, the side view, and also the isometric view using 1:5 scale, and we will see how it looks on this drawing sheet. So 1:5 means all the dimensions will be divided by 5, and that will be the dimension that we will use on the drawing sheet. Okay, so here is the drawing sheet I told you of A3 size, and on this drawing sheet I will draw the stool, the front view, top view, and the side view, and the isometric view, and show you how the scale that we have just now calculated, 1:5, how that fits here. So this is the drawing sheet, and I have done a small rough calculation. You should always do a rough calculation so that you can draw freely without any mistake. So here all the dimensions I have written down of that stool. So these are all actual dimensions, and this will be the front view that I will draw. So all the actual dimensions I have written down, but as I told you that I will use 1:5 scale, so all the dimensions will be divided by 5, and that's the dimension we will use here. So first the reference line. So reference lines should be somewhere in the middle so that you have enough space for the front view and the top view. But again, you can decide the position of the reference line based on the type of object you have, whether it is very tall or short. So these are the dimensions for the top surface of the table. So first I will start with the top view. So since this drawing will take a lot of time, so I have made the video very fast, and you can see the entire process of drawing that I have followed. But always remember, all dimensions I have used, the actual dimension has been divided by 5 to obtain the dimension on the drawing sheet. And the main objective here is to see whether our decision of 1:5 scale was correct or not. So this is the top view. Now I will draw the front view of this stool. So this is the height of the stool. These are the hidden lines, because in the top view these edges are not visible, but their existence is recognized by drawing dotted line, which is called hidden line. So the front view and the top view are almost ready, and we are drawing in the first angle projection system. So the image above the reference line is the front view, and the image below the reference line is the top view. Now we will draw the left hand side view on the right side. Now the side view is also ready. So we have got the front view, top view and the side view. Now we can do the dimensioning. For dimensioning, you should always remember that dimensioning is done only for solid lines or the view which is visible. For hidden lines, we never do the dimensioning. Now we will make the isometric view of this stool. So we will make this isometric view slightly below the reference line so that everything fits into this space. And we will start with a cuboid. So this stool can be fit inside a cuboid. So first we will draw the isometric view of a cuboid, and then we draw all the details. So this is the isometric view of a cuboid with the height as the same height of the stool, and the top surface has got dimension which is similar to the top seat of this stool. So whenever you can fit an object inside a cuboid, it is recommended that you start with the cuboid. So you draw the isometric view of the cuboid, and then you draw other dimensions so that they all fit inside this cuboid. You can watch another video in this channel on how to draw isometric view of any object. Now the top seat of this stool has got corners as rounded. So here we will use this French curve to draw this rounded curve. You can also use 4-box method to draw the isometric view of a circular object. But in this case, since the corners are very small, we can use this French curve and we can draw this curvature. So that kind of curvature is also in the legs of the stool. So isometric view of an object is never dimensioned, so we do not have to do the dimensioning here, but the scale is the same, 1:5. So we have used 1:5 scale for this. So now you can see that using our calculation and using 1:5 scale, we could fit everything within this drawing sheet. So now I will show you a scale which is used for reducing, or you can also use for enlarging scale. So this one is 1:100. So here you can see that the marking 10 millimeter is equal to 1 meter. So the measurement of 10 millimeter here represents 1 meter in actual size. So using this kind of scale, we can actually directly do the measurement. If we are using 1:100 scale, then we can use this scale directly without actually doing any calculation. So 1:100 scale is actually full scale. If you want to use as a full scale, you can also use full scale. In that case, you do not use the meter, but you just use the millimeter as it is in the form of full scale. But if you want to use it as 1:100 scale, then 10 millimeter will be represented by 1 meter. You can also make this scale as 1:10 or 1:100. This one is 1:200. So again, in this case also you can see these markings. So first marking is for so in the 1:200 scale, 25 millimeter matches with 5 meter. So this scale is for 1:300. So here you can see that the markings for 15 meter coincides with 50 millimeter on the actual dimension. In this scale of 1:250, we can see that the 5 meter coincides with 20 millimeter. So 20 millimeter represents 5 meter. So similarly, there are all kinds of scales here given. You can also buy some other for reducing scale, and this one is for, you can buy for enlarging scale. This one is for reducing scale. So we will do a simple measurement for 1:100. So for 1:100 scale, this 10 millimeter size actually represents 1 meter in actual dimension. So actual object dimension of 1 meter will be represented by 10 millimeter length on this drawing sheet. So let us do the calculation and find out the scale. So we can say that 10 millimeter on the drawing sheet is equal to 1 meter in the actual dimension. So therefore 1 millimeter on the drawing sheet will be 1000 millimeter divided by 10 millimeter. So this ratio will be given as 100 millimeter. So that means the scale, which is given as the dimension of on the drawing sheet divided by the dimension in the actual size, will be given as 1/100, or we can write the scale as 1:100. So if we are using this scale of 1:100, then we can use this scale and we can directly do the dimensioning without actually doing any calculation. So thus in this video we have seen what is the definition of a scale or drawing a scale, and then how can we calculate what kind of scale we should use for our drawing given an object. So the object can be very large or it can be very small. In either way, we should try to use the whole of the space of the drawing sheet, but again we should not go beyond the space, or we should not draw the object too small for a very large size of the drawing sheet. Then we also discussed the different types of scale that we can buy. So there are reducing scales and enlarging scales that we can buy. So using those scales we can directly do the measurement.